G'day guys, just doing a video of the answers to the practice test for this week. So skip ahead if you need help on a particular question, but I'll just start from question 1. We're solving the pair of simultaneous equations via graphing. Okay, so what we've got two equations, y equals x plus 1 and y equals 5 minus 1/3 x. Okay, what we've got to do is graph both of these lines and find where they intersect. Okay, so what I'm going to do is I'm going to start with the first equation. We've got a y-intercept of 1. Sometimes they just use c to represent the y-intercept. Okay, because that's that number by itself. Okay, we've got a gradient. That's that number that's in front of x. Okay, when there's nothing there, it's just 1. Okay, so if I was to do that in rise over run form, it'd be 1 over 1. And that's run. Okay, so I've got a pretty easy first graph to do. We've just got a y-intercept, and I'll do this in 1 in red. Y-intercept at 1. Okay, and what we're doing is rising and running one place each time. So I'm going up 1, across 1 each time. So up 1, across 1, up 1, across 1. All right, and that stays consistent. Okay, if I can go back the other way too. All right, so what you do now is you get your ruler out. Just make sure you draw a straight line between the points. If you want, you can just have 2 points and then use your ruler and just make it consistent. Okay, so this equation was y equals x plus 1. All right, what I might do is I'll use blue for the other equation. So I've got a gradient. So I'll start with the y-intercept. We've got a y-intercept here of 5 because that's that number by itself. And I've got a gradient here of negative 1/3. Okay, with the negative, guys, you can apply that to either number. Okay, so what I mean by that is you can apply it either to the 1 or the 3. What I'll do, I always do it, is I'll just apply it to the 1. Okay, I'll show you what that means. So what we're gonna do is we're gonna start with our y-intercept. It's up here at 5. Okay, then we use our gradient. If we think about it, it's rise over run. What I'm going to do is I'm going to have the negative as the rise part. So if I'm rising -1, it means I'm actually going down one place. Okay, then the run, that part's positive because I've applied the negative to the rise. So the run is still going to be positive, so it's running 3. Okay, so that dot's there. Okay, so that stays consistent. It's going down one place, across 3. All right. So get your ruler out and draw a line between those two. Just going back, what I mean by that negative, I might just rub that out. Just by what I mean, if it doesn't really matter. If I apply the negative to the 3, so I'm rising one place, going back 3 places. That means I'm going up 1, all right, and back 3. 1, 2, 3. Okay, which I've run out of grid paper here, but if you see that gradient, that fits on the line too. Okay, so it doesn't actually matter which number you apply the negative to. Just out of habit, I always do it to the top one for my rise, but yeah, just covering that. Okay, so we've got our two equations. Y equals 5 minus 1/3 of x. Okay, so our solution, where they cross over, this point in here, okay, that is when x equals 3, okay, and when y equals 4. Okay, so if you want to do it as coordinates, 3, 4. All right, next question. Okay, so we've got two other graphs. Got to find the intercept. So if you look at our first graph, we've got 4x minus 2y equals 10. There is actually a way you can graph these equations without having to rearrange them to y equals. Okay, it's called the intercepts method. Okay, you should have learned it last year, but what I'll do, because I haven't covered that much just in simultaneous equations, I'm going to just rearrange this equation, okay, to get y by itself. All right, so what I'll do is I'll write it back down here just so I get y by itself. So I've got 4x minus 2y equals 10. Okay, and my goal here is just to get y by itself so that I can find the intercept, the y-intercept and the gradient. Okay, so I'm going to get rid of the 4x. I want to get that onto the other side. Okay, so that leaves me with negative 2y equals 10 minus 4x. Okay, now what I want to do to get this y by itself, divide both sides by negative 2. Okay, which leaves me with the equation y equals, okay, 10 divided by negative 2 is negative 5. All right, and negative 4 divided by negative 2 makes positive 2x. All right, so this graph is for this first one at the top. So what I might do is I'll graph that one first. Okay, so I've got a y-intercept, that number by itself, of negative 5. And I've got a gradient of 2. Okay, so if I wanted that's rising 2 places, running 1. Okay, I'll do this one in red. So I've got a y-intercept at negative 5. Okay, and then this graph is rising 2 places, going across 1 each time. Rising 2 across 1. Cool. And I'm just rising 2 across 1 consistently. All right, what you can do now, get your ruler out. Do a straight line between those. Not a very good one, that one. Cool, and that's our first graph. Y equals negative 5 plus 2x. All right, the second one's a bit nicer. I'll do that in blue. We've already got it in y equals mx plus c form. So our intercept is this 3. Remember, that's just the number by itself. Our gradient is negative 2. So I can have that as negative 2 on 1. Cool, so what I'll do is I'll graph that y-intercept at 3. I've got a gradient that's going down 2 places and across 1. So 1, 2, and across. 1, 2, and across. 1, 2, and across. Okay, so we've already found our intercept, but I'm just putting a few more dots in. When you do it, guys, you don't have to draw these squiggly lines that I'm doing. I'm just trying to show you that the rise and the run, so the down 2 across 1. Like if you want to just do it in your head and just put the dots in, like if I do this other dot up the top, okay, you can just do it straight in your head. You don't have to put the squiggly lines. I'm just trying to show the rise and run of it. But then we are going to have a straight line between those dots. Okay, and because it's annoying me, I might actually scribble out, I might rub out these I can't get them all, but little things. It's right in there. Okay, so our graph, it was intersecting. If you look at that point of intersection, it's when x equals 2. Okay, and when y equals negative 1. Okay, so if you want it as coordinates, 2, negative 1. All right, so that's simultaneous equations by graphing. Okay, over the page. Okay, so the next questions will be by substitution and elimination. Okay, so question 3, solve this pair of simultaneous equations using the substitution method. Okay, so with the substitution method, guys, always substitute the one that's in, so either x equals or y equals. Okay, it may not always be those variables x and y, but whichever one has like x equals, y equals, okay, that's the one that you're going to sub into the other equation. Okay, so if we look at this top one, we know that x equals 2y plus 4. So instead of having x in the second equation, what I'm going to do is I'm going to put that in place of x. It's meant to be an arrow. In place of x. Okay, so what I'm going to do is I'm going to rewrite the second equation out. So it's going to be 2y minus 4. Okay, and then I'm going to substitute that other part in. So it's going to be 2y plus 4 equals 2. Okay, the reason we do that is so now we're just dealing with y's. Okay, and we can solve this equation. So my next line of working, I'm going to actually expand these brackets. Okay, I probably haven't left myself enough room here, but it's going to be 2y minus negative 4 times 2, negative 8y. Negative 4 times 4 is negative 16 equals 2. Okay, what I can do here is I can probably do two things at once. I can collect the like terms. So I might just do one thing at once. I've got 2y and I'm taking 8y. So if you want to use it in real terms, you get 2 yabbies. Okay, somehow someone takes 8 yabbies off you. Okay, you're left with negative 6 yabbies. Okay, and then what I'm going to do is I'm going to add this 16. We want to get that to the other side. Okay, so 2 plus 16 is 18. Cool. All right, what we're going to do now is solve for y. So to get rid of that negative 6, divide both sides. All right, y equals negative 3. Okay, and what we're going to do now, hopefully I've got enough rooms. I'm going to substitute that, and it doesn't matter which one you substitute it in. You're going to substitute that into one of the equations. What I might do is I'll substitute it into the top one. One, because it looks nice and it's already in x equals. So I'm going to have, in place of that top equation, x equals 2. And instead of the y now, it's going to be times negative 3, because that's the value of y, plus 4. Okay, so x equals, what, negative 6 plus 4. Okay, so x equals negative 2. All right, there is your solutions to the first, or question 3. I'll just split that off. All right, question 4. Okay, we've got to use substitution again. Okay, this time you can see that the second equation, so we've got 3x minus 2y equals 18, and y equals 2x minus 5. You can see that the second equation, oh, my arrows are bad. Second equation, okay, is the one that starts with y equals. So what we're going to do is this 2x minus 5, that's the value of y. I'm going to substitute that into y for the top equation. Okay, so what I'm going to do is I'm going to rewrite out that top equation, so 3x minus 2. Okay, instead of the y now, you can have 2x minus 5 equals 18. Okay, once you get to here, we're just going to expand these brackets. So we're going to have 3x. All right, negative 2 times 2 is negative 4x. All right, negative 2 times negative 5 is positive 10. Equals 18. Okay, again, I can collect the like terms. So I've got 3 take 4x. So that's going to leave me with negative x. Okay, and if you wanted to do two things at once, you're also going to take this 10 to the other side. All right, so 18 take 10. It's going to be 8. Okay, with this negative, guys, that's saying negative 1 times x. So to get rid of it, just divide both sides by negative 1. Okay, so then you finally get x by itself. And if you divide it by negative 1, all you're doing is just changing the symbol. Okay, so we had 8 divided by negative 1. It's now negative 8. Cool. I'll split this up. what I'm going to do now with that -8 is I'm going to substitute it into one of our original equations. Okay, looking at our two equations, the second one is nicer because it's already in that y equals form. Okay, so what I'll do is I'll rewrite that equation out. Y equals 2, and instead of x, now it's -8, so times -8 minus the 5. Okay, so y equals 2 times -8 is -16. Right, minus the 5. Okay, so y equals -16, take 5, gets you to -21. Cool, and there's your answers for that one. Righto, I've gone a little bit over the other question. Question 5, now we're starting with elimination. Okay, the other method. Okay, this method is better when you don't have both like either equation in a y equals or an x equals form. Okay, we can see in our equations we've got x minus y equals 10, x plus y equals 12. You could rearrange them if you wanted to use substitution. But yeah, it wants us to use elimination anyway. But elimination is best. What we're trying to identify is the coefficients. Okay, so we're trying to get the same coefficients for x. What I mean by coefficients is the number in front of x. Okay, and we're trying to get the same coefficients in front of y. Okay, don't worry if they're negative or positive. Okay, if we look at this equation, we can see that both the x's and both the y's, right, they match up. So the x's have 1s in front of them, y's have 1s. So we're good for our coefficients. Okay, then to use elimination, what you've got to do is we're trying to get rid of one of the variables by adding and subtracting the two equations. Okay, so if we look at our two equations, what I might do is I might get rid of the y's. Okay, it doesn't matter if you decide to get rid of the x's, but I don't like dealing with negatives. So what I'm going to do is I'm going to actually add these two equations together. Okay, because we've got a negative y and a positive y, so they'll cancel out. So I'll just be left with x's. So remember, guys, you add or subtract, you do it vertically. Okay, so what I'm going to do is add the x's together. Okay, that makes 2x. If I add the y's together, it's going to cancel out. And I add the 10 and the 12, that makes 22. Okay, divide both sides by 2. All right, x equals 11. Sweet, easy as that. Once you've done that, same as substitution, you just put it back into one of the equations. It doesn't matter which one you choose. I might choose the top one. Actually, no, I'll choose the bottom one, so I'm not dealing with negatives. You're going to get the right answer anyway, but I'm choosing the bottom one. So instead of x, I've got 11 plus the y equals 12. Okay, and then to get that y by itself, minus the 11 of both sides, y equals 1. All right, getting through it. Question 6, okay, we've got simultaneous equations again. We want to use elimination. Okay, 3x minus 4y equals 13, 5x plus 3y equals 12. I might zoom in a little bit. All right, this time if we're looking at our coefficients for x's, the x's and the y's, we can see that none of them, or the pairs, okay, they don't match up. Okay, so what you got to do is you got to multiply the top equation and the bottom equation to try and match up either x's or y's. So you can do it either way. For me, and there's no right or wrong, like if you've decided to, times the top equation by, if I can get my pen, top equation by, so I'm just going to have to move this. If you decide to multiply your top equation by 5, your bottom equation by 3, okay, match up your x's, that's fine. What I'm going to do though is I'm actually going to match up the y's. Why, you might ask? Okay, I see the multiplication's nicer. I've got a 4 and a 3. Okay, and so I'm going to times the top one by 3, top one by 4. If you're ever wondering what do you multiply mine to match up, just multiply it by the other one. So I'm matching up the y's. And also, yeah, smaller multiplications might be easier for me to do. Oh, sorry, the other thing was I've got a negative and a positive. Okay, and I like adding them together. Anyway, okay, so I'm going to multiply the top equation by 3. Okay, so 3 times 3x is 9x. Negative 4 times 3 is negative 12y. Okay, and 13 times 3 is 39. Okay, 4 times 5 is 20x. 4 times 3 is 12y. Okay, and then 4 times 12 is 48. Okay, and as I said, we want to eliminate those y's. We've got a negative and a positive. Okay, so we're going to add them together. Okay, so when you're working with these equations now, guys, you work vertically. Okay, so you put that arrow if you want. Doesn't matter, but now we're going to do 9 plus our 20x. 9x plus our 20x makes 29x. Okay, our y's cancel out. Okay, 39 plus 48 you can do on your calculator if you want. I think it's 87. All right, so now what we're going to do is we're going to solve for our x's. Okay, divide both sides by 29. I wonder if you did it with the x's, if you had a nicer, like if you did it the other way, if you had a nicer answer, nicer numbers. Okay, 87 times 29 is 3. Okay, I don't know my 29 times tables. I just know that 9 times 3 is 27. Okay, so I just know that it fits in like that. Cool, so x equals 3. All right, now what we're going to do is we substitute that into one of our original equations. Okay, so I might choose the top. I'll choose the top one. So I've got 3, and in place of the x, I've got 3. Okay, minus 4y equals 13. Okay, so 3 times 3 is 9. Minus the 4y equals 13. Okay, what I'm going to do to get y by itself now is minus the 9 to both sides. Okay, which leaves us with negative 4y equals 13. Take 9 is 4. Okay, and lastly, divide both sides by the negative 4. Okay, so y equals negative 1. Cool, and there's our solution. Righto, last page. All right, we've got our worded problems now. Okay, question 7. Looks like we've got Lani. Lani's bought 4 apples, 2 bananas, and that cost her $1 in total. Okay, her cousin Tess, not sure if you guys are cousins, but Tess has bought 2 apples, 6 bananas, okay, and that's cost her $1.50. Okay, how much did each piece of fruit cost? Okay, so guys, if we think about our worded problems, okay, we're trying to make 2 equations, all right, and we have 2 variables or 2 unknowns. Okay, in this case, we're trying to find the cost of each piece of fruit. Okay, so our pieces of fruit, we've got our apples. Okay, I'm going to give them the letter A. All right, we've got our bananas, B-A-N-A-N-A-S. Bananas is always something. It's always got that song has helped. Okay, bananas equals B. Right, what we're going to do is create our 2 equations. Okay, so Lani, she bought 4 apples, so 4A, and she bought 2 bananas. All right, and that cost her $1. Okay, so that's our first equation. Then Tess, when she went to the supermarket or the market, She bought 2 apples and 6 bananas for $1.50. Right, what we do now is, once we've got our 2 equations, is we're going to try and solve them. Okay, I think solving them by elimination is the easier way. Okay, I'm going to actually match up the A's as well. So if I want to match them up, okay, I can times this bottom equation by 2. Okay, so I might do that now. So I get 4A, okay, and 6 times 2 makes 12B, which equals $1.50 times 2 is $3. Okay, so what I'm doing now, guys, is I'm just focusing on our first equation, right, and the equation I just created. Okay, we want to eliminate the A's. We've got 2 positive. Don't worry about the what I've got here. All right, we've got 2 positive 4s. Okay, so to eliminate them, I need to subtract these 2 equations. All right, which I might do. Give myself a bit more room. Might do over here. Okay, remember you're working vertically. Okay, ignore the middle numbers. Okay, so 4 take 4 eliminates that. 2 take 12 is negative 10B. All right, and then $1 take $3 is negative $2. Okay, then what we're going to do is divide both sides by the negative 10. Okay, you can see when we divide by the 2 negatives, that's going to make it a positive. So think about it as just $2, like the 2 negatives cancel each other out. So it's going to be $2 divided by 10. If you've got $2 and you've got to split it into 10 parts, okay, that's going to leave you with 20 cents. So the bananas cost 20 cents. Now what we're going to do is find the price of the apples. Okay, so I might substitute it into the first equation. Give myself some more room. Okay, so we're going to have 4 apples plus 2 times, instead of bananas, 20 cents equals $1. Okay, which leaves me with 4 apples plus 2 20-cent pieces make, you got 40 cents now. So $1. All right, what we're going to do now is get these apples by itself. So minus 40 cents from both sides. Oof, running out of room. So we've got 4 apples equals, okay, you have $1. You're taking 40 cents away. Okay, now you got 60 cents. Righto, and to find the price of these apples, divide both sides by 4. Okay, apples are 60 cents divided by 4. Okay, should be 15 cents. Cool, so the apples are 20 cents. Sorry, the apples are 15 cents, the bananas are 20 cents. All right, last question. Farmer Chase. Not sure if Chase is a farmer, if he's on a farm, but he's got a paddock. Okay, it contains goats and emus. As he is in his declining years, his eyesight is failing him, poor Chase. Okay, and he's had trouble telling them apart. Okay, what he can see is that there are a total of 84 heads, 246 legs. Sorry, I'm just straightening this up. How many goats and emus does Farmer Chase have? All right, so if we think about our variables, we've got 2 animals. Okay, we've got goats. I'm going to give them G. Okay, and we've got our emus, which equals E. All right, what we're going to try and do is make our 2 equations. Okay, the question, sort of all the first part's all sort of gibberish. If I just read from this blue line on, that's where we're going to get our equations from. It says what he can see is that there are a total of 84 heads and 246 legs. Okay, how many goats and emus does Farmer Chase have? So if you think about our animals, guys, we can make two equations. One can be in relation to the heads, okay, and the other equation can be in relation to the legs. Okay, so if we're thinking about the heads, the total heads that he sees, okay, he sees 84 heads. Okay, in relation to the legs, he sees 246 legs. So it's going to equal those amounts. Okay, then we've got to think about the actual animals. Okay, so goats, we think about how many heads and legs they have. Oh, sorry, not the legs. If we think about goats and just their heads, all right, each goat has one head. So I'm going to just write one goat. Okay, if we think about emus, okay, every emu has one head. Okay, so each goat and each emu are contributing one head towards the total 84. Okay, then the legs. Okay, if we think about goats, okay, goats have got 4 legs. Okay, then the emus have 2 legs. All right, and that's going to help contribute towards the 246. All right, now what we're going to do is we've got our 2 equations now. Okay, that's the hard part. Now what we're going to do is just solve for them. If I look at my coefficients, I can see that I've got a 1 and a 2 for the e's. So what I'm going to do is do this by elimination. I'm going to times this top side by 2 to get the e's to match up. Okay, so if I multiply that top equation by 2, I get 2g plus 2e equals 84 times 2 is 168. Okay, so now I've got my 2 equations here. Okay, I'm going to subtract them. Okay, because that's going to eliminate the e's. Okay, so maybe you do it vertically. 4g take 2g is 2g. Okay, the e's cancel each other out. And this will test me. 246 minus 168 is what? 8. Is it 78? 78, I think. 78. I hope I'm right with that. Oh, Monday afternoon, I'm tired too. I'm pretty sure it's 78. I'll just quickly check. Don't want to stuff that. 246 minus 168. Cool, 78. All right, what we're going to do now to solve for the number of goats, divide both sides by 2. Okay, goats equals 39. So we've got 39 goats. Okay, what we're going to do now is substitute that into the first equation because it's nicer to find the number of emus. Okay, so it's going to be, instead of goats, it's 1. Like if you think of just 1g, it's just going to be like our goats are 39 plus 1e, I'll just write e, equals 84. Okay, to the solve for the number of emus, minus both sides by 39. Okay, so the number of emus that Farmer Chase has is, oh, my head hurts. What's that, 45, is it? 45. I'll just check. I'm tired now. Yep, 45. All right, now that's the answers for the practice test. So good luck, guys. Just send me a message if none of it makes sense. Remember to go back and look at any parts that you need.